A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm the same. Thank you. We shall be starting in a couple of moments, guys. So, hello, a very warm good afternoon to all of you, and welcome to Baiju's Exam Prep IAS. Welcome to another session of climatology, where today we shall be initiating the discussion where we left off last weekend, that is at the portion of humidity and precipitation. So last weekend, we had initiated the discussion for climatology, where we discussed the basics about atmosphere, right from the time of the atmospheric formation to the evolution of atmosphere as it has happened throughout the history of the planet. We have seen that the gas which basically provides us life, that is oxygen, that has been added much later on into the planet's atmosphere, and how all the various components from dust particles to water vapor to the various different gases, how they all play a major role in shaping the life that we see around us, in sustaining the life that we see around us. Now, overall, when we talk about this particular aspect where we talk about the atmosphere, we have to understand that the atmosphere ends up receiving substantial amount of heat upon getting heated from the Earth's surface. So that is one of the major sources of heat addition into the atmosphere. And that is why as we move higher up from the surface of the planet Earth, the temperature in the atmosphere starts reducing. We have seen the aspects of heating and cooling where we observe that how land and water ends up getting heated up and cooled down at different rates and different proportions. We have seen that the land area gets heated much faster, whereas it also loses heat quite suddenly. We have understood the concepts such as temperature inversion, the various different types of temperature inversion. What do we understand by pressure? Thermal pressure, dynamically induced pressure, where we have seen also with the help of this development of pressure that always the winds will flow or blow from a high pressure to a low pressure, always. That will be a kind of a consistent pattern that you will observe. Now, after that, we also observed that there are in presence the permanent wind systems which are in existence all across the planet, where the winds, they generally blow from the high pressures which are created, and the high pressures and the low pressures created across the planet, they are both thermally induced as well as dynamically induced. Now, we have taken a look at the local wind systems as well. And then we moved on to understand the concepts of humidity, cloud formation, different types of clouds which are in existence. We have also taken a look at cloudburst, hailstorms, and now we are going to initiate the discussion about the types of rainfall, the types of fog formation, and that will help us understand the various events of rainfall which are occurred, which are observed during cyclonic events and cyclonic circulations as well. How is it that the cyclones, they get created? How is it that they are named? And we will find a pattern in terms of that naming and the pattern in the formation of those cyclones. After that, we shall be initiating the discussion about the various atmospheric phenomena, such as Walker circulation, El Nino, La Nina, and also the concepts involving Indian Ocean dipole, Madden-Julian oscillation. And all of that will eventually lead us to discuss and understand the Indian monsoon. Indian monsoonal phenomena is one of the most important phenomena in climatology that you need to get a very clear concept about. So all these things, they are basically a precursor for us or leading us to help understand that particular complicated concept. And after that Indian monsoon, Then we are going to study about the world climate and how is it that there is a climatic distribution and a climatic pattern experienced all across different parts of the globe. Okay. Now, okay, I have a question from Pulkit. Pulkit, your question, which I had replied to on the mail as well, was your question was that how is it that River Brahmaputra can be antecedent if River Brahmaputra has changed its course due to the uplift of Himalayas? Understand what is antecedent river. Antecedents of any particular river is basically when the river has been in existence before the formation of that particular landform. That is associated with the antecedents of the river. Now, when we talk about River Brahmaputra, it blows or it rather flows into the northern part of the Great Himalayas. And there it takes a sudden southward bend around the region of Namcha Barwa. Now, after taking a bend, it does cross through and cut through the different other ranges of the Himalayan mountains. So, if the question is why does it take a bend? Why doesn't it simply go through the region of the central Himalayas as well? Why doesn't it continue to move in the further eastward direction? That is because as the upliftment was happening, there was an uplift of the Tibetan highlands also, which were happening. Understand, as long as the upliftment is in a slower proportion, in a very slow rate, the cutting down can be made possible by the river. But if the uplift is very sudden, that means the river will be bound to change its course. So, because the entire topography in the northeastern part of India was forced to rise up, was forced to basically uplift. Now, as a result of that, this river did not have enough force to cut through that uplifted mountains and the uplifted topography through and through. But then, after that change in course, there also it cuts down a very deep gorge at Namcha Barwa. And after that, it manages to cut through the other ranges of the Himalayas, making Brahmaputra an antecedent river. I hope that is understood. And Jagati, I've been suffering from some health issues. I'm not preparing well. 2024 attempt I will not clear. Jagati, please understand, if even if let's suppose your preparation is not to the mark till now, does not mean it is the end of the world. Even from now on till the time of your prelims examination, you can have a much greater chance of clearing the prelims examination if even now if you get your act together. All that you have to understand is what is required to be studied for the various different subjects, and you cannot go for selective study basically, but you have to cover these subjects. If you have attended the sessions, recorded lectures are available to you. There is no reason why you would not be able to clear the prelims examination, even if let's suppose from a very basic point you start your preparation from today. Make each and every day count, because let me tell you what generally happens with many of the candidates is that they procrastinate, that this year the preparation is not well, they will move on to the next year maybe by the month of October and November. If your preparation is not streamlined, you already are habituated for skipping the examination, so you start exploring alternate career options. So basically you end up wasting 2 years of your life for nothing. So if you are very certain that this is the examination that you need to clear, you can start from now itself. Let's suppose in this attempt you don't end up securing a single digit rank or a double digit rank, but still you have enough time to get your name into the merit list. We have seen candidates starting the preparation from this point onwards, and just because they have managed to dedicate themselves, they have cleared the examination. So there is ample time even now. Okay, I hope that is understood, Jagati. And any more questions that we have? Parshuram, about Tej cyclone is important for UPSC. UPSC never asks you the name of the individual cyclones. It does ask you about the formation of cyclones multiple times. It does talk to you about, or it does require the candidates to know about the process of naming of the cyclones, that how is it that the cyclones have been named. So those are the important factors and parameters that one needs to keep in mind. Okay, right? No, Niranjan. Not required. Vedika, I'm facing trouble in covering previous classes as I started late. So, see, at one point of time, if you think that you will be able to cover all the entirety of the previous sessions, that will be very difficult. That is why when you are covering the previous classes, set a target that in these 3 days I will cover these many modules of, let's suppose, the subject of polity, these many modules for revision for the subject of geography. Set those targets. By the time that we are done with the completion of geography syllabus, you will be able to revise the previous ones by that point of time very ably well. Anyways, we have moved very slowly in our coverage of the syllabus till now, so automatically you will have some amount of leeway, and it will be flexibility will be there with you. So try covering it, initiate that portion. The moment you initiate that revision process, you will get an idea about the timeline as well. Okay. uh, Ankit, any one of them, wherever the syllabus appears to be conducive, look at the syllabus from the notification. Wherever the syllabus appears to be conducive, don't think about it that sociology if I take I'll get more marks, anthropology if I get more marks. Which is the subject you are more comfortable with? If you are good in writing skills, take sociology. If you are good in analytical skills, PSIR would also do, or anthropology rather. If you are good in analytical skill, anthropology. Written skills, PSIR. Pulkit, you have another question that I'm not clear that what was the source of the river for such. So the source of the river, in case think about it, in the peninsular region, the peninsular India, do you have any snow-covered peaks and mountains which give rise to the rivers in existence? Absolutely no. So wherever you have in any region an accumulated amount of precipitation, substantial amount of precipitation concentrated in a particular region, that can become a source for the river movement in any of these areas. Siddhya, is UPSC only for them who are toppers in academics? Absolutely not. You'll find the masses who clear the examination, they have never been toppers out there. It is only the 5 to 7 people or 5 to 10 people in the merit list that you come across who have been toppers through their lives, or at max around 40 to 50 people. The difference is that these news headlines, they make stories, they make good social media accounts. So that is why the perception is that you have to be a topper through your school, through your graduation days, in order to qualify for the examination. But the reality is very far away from what you perceive. Akshay, I have a problem with breaking of video in between every day. I can assure you there is no network issue at my end. Okay. So do one thing, Akshay. Whenever you have this particular kind of an issue, take a screenshot of them, have the timestamp of that, and send a detailed mail to the IS Live, so that we can have the tech team take a look into it, so that we can analyze if there is an issue from our end or if there is an issue at your end. Because the other candidates, they are not facing this issue. So we would need a kind of a detailed mail that you can send. Okay. Because I'm an engineering student and I can't understand maths much. Maths is not required for this. And anyways, if you are an engineering student, you would have the basic capacity to solve CSAT questions. That is all that is required out of maths in this entire preparation. Okay. Pulkit, one last question. Harry has found oceanic crust in Atlantic Ocean to be nowhere older than 200 million years. And we got an idea that Atlantic Ocean was not in existence before, but sir, going by seafloor spreading theory, isn't it possible that Atlantic Ocean had been there prior to 200 million years? No, but then the evidences of continental drift, they indicate that North America and Europe, they had the mountain formations happening at the same time. You have the evidences in South America in terms of the gold source, the source rock for the gold, and the placer deposits in Africa. Similarity of paleontological evidences that you find between South America and Africa. All of them indicate that these continents were together. So And furthermore, to add on to the evidence that Atlantic Ocean was also not there before 200 million years. So that again puts into the perspective that these regions would have separated close to around 200 to 235 million years back. Okay, it is a culmination of all those evidences. Okay, so now we initiate the discussion from the portion of types of rainfall. Madhuri, the mail ID you were seeking, this is the mail ID. Okay, you can contact me on the mail ID. Kunal, ideally, you should be able to score 50% marks in the subjective test. That is basically if the question is of 10 marks, you should be able to secure around 5. If the question is of 15 marks, you should be able to secure somewhere in the region of 7 to 7.5, or if it is good, 8. So take a look at the feedback given to you by the evaluator. Try to incorporate that into your answer writing as well. Okay, that is the only way to improve and to write as much more answers as you can. Please understand, again I will reiterate, that improvement in answer writing is observed only after you have written close to around 50 to 60 answers. Then the next answer that you will write will show a kind of a marked improvement if you have tried to incorporate the feedback by evaluators. One of the problem with the candidates has always been, and that is not for you, that is not for me, it is common across all the candidates, that when they take a look at the feedback given by the evaluators, they always pin the blame at the evaluator that the evaluation is not nice. Please understand, that is a luxury that is available to you now. When your copy goes out for evaluation in the case of civil services mains, you will have no such scope to convince the evaluator later on or put a complaint out there. So that is why whatever comments and feedbacks are given by the evaluator, incorporate it immediately. Okay. For evaluation of answers, send it to us at IS Live, Target IS, send it to us and we'll get it evaluated. Okay. For the evaluation of answers, you can send it to us at Target IS or IS Live, and you can write that this is a paper for evaluation. We'll get it evaluated. No issues. Akshay, I want to prepare for geography as optional subject also. So for that, Akshay, you would need to see in this portion of GS discussion, we are going to cover comprehensively close to around 55 to 65% of your optional syllabus also. But you need to cover much more than that. So I had given the book list in the first class, in the first session of the class itself. You can take a look at the recordings. If not, then remind me sometime before the end of the session. And just before the end of the session, I will give you the name of the other books that you need to go through and the other areas that you need to cover if you want to cover it for the optional preparation. Okay. Now we start with the portion of the types of rainfall. But before looking into that, let us start with the question from the area that we have already covered. So which of the following statements is correct? Cirrus clouds are composed of ice crystals. Cirrus clouds have a flat base and appear as rising domes. Cirrus clouds are white and thin and form delicate patches and give a fibrous and feathery appearance. Cumulus clouds are classified as high-level clouds. So which of the following statements is going to be correct? So I'll give you 30 seconds of time. Think about it. Properly read each and every statement and answer. Okay. So a majority of you, by a very thin number, have given the correct answer. Let us analyze these options and let us try to understand whether they will be correct or incorrect. Cirrus clouds are composed of ice crystals. Cirrus clouds are considered to be very high level clouds, which are formed close to around 10 kilometers, 6 to 10 kilometers above the Earth's surface. So obviously, ice crystal formation will be observed there. Cirrus clouds have a flat base and appear as rising domes. Which of these clouds or which of the cloud types have this particular shape, where they are flat at base and appear as rising domes? Let me know. Is it the cirrus cloud or is it some other cloud? It is? You don't have anything as cirrus nimbo. Good, Shahid. This is your stratocumulus. Okay? So the second statement is incorrect. Cumulus clouds, which are low level clouds, are white and thin and form delicate patches and give a fibrous and feathery appearance. So cumulus cloud, which is a low level cloud, will not be able to create that. So which cloud gives you the white and thin and delicate patches and give a fibrous and feathery appearance? Let me know. Cirrus. Very good. So this is incorrect. Here it will be cirrus. Then cumulus clouds are classified as high clouds. This is incorrect. Cumulus clouds are basically classified as the low level clouds. So the correct answer in this will be A, that is cirrus clouds are composed of ice crystals. Okay? Now, let us move on to the topic, that is the types of rainfall. So when we receive rainfall, now rains are received all over the world, almost all over the world, other than few areas across the poles, it is received all over the world. Now these rainfall or the rainfall which happens can happen because of the certain conditions only. Now, based upon why that rainfall is caused or is created, you can have the classification of the types of rainfall into convectional rainfall. You can have orographic or relief rainfall or cyclonic or frontal rainfall. Now we will talk about each one of them separately as well. But just to give you a brief preview of sorts, when we talk about convectional rainfall, the name in itself tells you that this is initiated because of the process of convection. And what is this process of convection? Where the warm air tends to rise up, right? As the warm air basically tends to rise up, eventually there will be cooling down of it, and the vapor in that air will condense and will form that cloud formation, and eventually that cloud can give rise to rainfall. So, caused due to convection in the air. Simple. Then when we talk about orographic or relief, so remember in the time of discussion during geomorphology, at that time only we had this discussion that anything dealing with orography, orogeny, always deals with a kind of a mountain or a kind of a hill formation. So orographic or relief rainfall here basically talks about any kind of rainfall which is created due to a physical barrier. Physical barrier can be present in the form of a hill, it can be present in the form of a mountain. Now, in those cases, what happens? As the air or the moisture laden winds, as they end up hitting a physical barrier, then they are forced to rise up. Now, as they are forced to rise up, they will obviously be cooling down, they will be losing their temperature, and all the water vapor will eventually condense into liquid water droplets. So that is where you will have a kind of a cloud formation in this area. It can cause substantial amount of rains. Okay, so this is caused because of a physical barrier, due to physical barrier offered by the topography. Okay, And then you have cyclonic or frontal rainfall. So cyclonic or frontal rainfall, basically wherever you have the existence of a front, and sometimes even due to low pressure which is created, that will attract winds from all different direction, and that can end up creating the rainfall, but mostly observed across frontal areas. So let us take a detailed look at each one of them. Let us try to understand where do they cause rainfall and how do they bring about rainfall. So starting with the convectional rainfall. Now, convectional rainfall, as we have already talked about, that it is because of the convectional movement in the air. And what do we mean by the convectional movement? So, during the day, when the ground gets heated up, that is when the air immediately above the ground also receives substantial amount of heat. Now, the air, when it warms up, basically the ground surface also getting heated up will give rise to more evaporation. Now, you have a lot of vapor present in the air, which is warmer. So, that air will start to rise up. Now, when that air rises up, after reaching a particular height, it will cool down in the process. And it cools down, in the sense, loses its temperature. There is some condensation which happens, and that condensation brings about cloud formation and leads to occurrence of rains. So, convectional rainfall basically is observed around the equatorial areas and around the region of the islands, right? Especially tropical islands is where you will observe a lot of this phenomena happening, because during the day, throughout the day, there is substantial amount of heating, substantial amount of evaporation. So by the evening, that is 4 p.m., 5 p.m., you will observe a very thick cumulonimbus cloud getting created, and you can have daily occurrence of rainfall generally in the evening. So observed in the equatorial areas, in the equatorial regions, and basically also when we talk about the equatorial regions, also in case of tropical islands. So the process of formation is, or occurrences during the day, heating is received, that leads to substantial amount of evaporation. Evaporation. Air rises up and cools down. That means there will be condensation and cloud formation. And we had talked about last week also about the fact that when there is significant amount of evaporation, it will lead to some or the other form of cumulus cloud, right? Evaporation basically means that there will be condensation in chunk around an area, so it will appear like a heaped up ball of cotton of sorts. So cumulus clouds are always created when the cloud formation is only associated with evaporation happening. So cloud formation by late afternoon, you have cumulonimbus clouds. Okay, and these cumulonimbus clouds basically eventually they will bring thunder, lightning, and evening rains or afternoon rains. And these rains will occur on a daily basis. Okay, In these areas, that is why around the region of equator, you experience that rainfall is observed and is received on a day-to-day basis. Every day around the evening time, you will end up receiving rainfall. Okay, so that is the process of convectional rainfall as is observed. Then after this, we move forward to another kind of rainfall, which is generally observed across large parts of India. And that is the rainfall which is caused due to orographic conditions. Now, we have already seen that when we talk about a physical barrier such as a mountain, now a mountain will have two sides, that is windward side and the leeward side. The side which is facing the wind, that will be referred to as the windward side. This will be your windward side. This will be the leeward side. Okay. Now, the side which is facing the mountain, facing the wind, basically, if you have moisture bearing winds, moisture carrying winds, now these moisture carrying winds, basically, when they hit these mountains, moisture carrying winds, they will hit these mountains and they will be forced to rise up. Okay, and when they are forced to rise up, they will lose their temperature, they will cool down, and they will bring substantial amount of cloud formation in this area. Substantial cloud formation, which will eventually bring rainfall on the windward side. Now, after that, the air which is present, the air would have become completely dried out, because whatever amount of water vapor would be present in the air, that or the wind, that water vapor would have been utilized in the cloud formation and occurrence of rains. So the air which is going to emerge after that is going to be dry. Okay. And then as the air starts sinking down the slope, as it starts moving down the slope, it undergoes what is known as adiabatic compression. Adiabatic compression, as the air goes from a region of less air density to a region of a high air density, it goes for adiabatic compression. And that is when the air becomes warm. Okay, so this is where the air becomes, on the leeward side, it becomes warm and dry. That is why the leeward side of the mountains, they are generally deprived of rain. And that leeward side of the mountain, that is also referred to as the rain shadow region. When we come to the portion of Indian monsoons and Indian climate, basically we will observe that the majority of the rainfall received in different parts of the country, that is shaped because of the orographic conditions. Be it the rains that you receive in the region of the central India, such as Madhya Pradesh, Chhattisgarh, or be it the less rains which are received in the region of northern Karnataka, in the region of Telangana. All of these, or excessively high rainfall received in northeastern part of India, or complete lack of rainfall received in the or experienced in the region of western part of Rajasthan. All of these are basically created due to what? Due to orographic factors. And that is something we will study. So, whichever portion lies on the leeward side, whichever region lies on the leeward side, generally that region is deprived of the occurrence of rainfall. And the region which lies on the windward side, that is the region which will always end up receiving higher amount of rainfall. So this is your rainy area. Okay. So rainfall is received on windward side. Generally with this also, you will observe the formation of cumulus or cumulonimbus, but sometimes you can also have nimbostratus clouds getting created. Okay, but generally you will have cumulus and cumulonimbus cloud formation, mostly cumulonimbus cloud formation observed when you have these orographic factors. Okay. Parshuram, acid rain is also part of convectional rainfall. Parshuram, my dear friend, acid rain is what? Do we know what do we mean by acid rain? And why that acid? Is it because somewhere there is some acid and that acid has reached the cloud and that acid is raining down, and if you get exposed to it, immediately you will have fumes emerging from the body like you see in the cartoon movies? Is that acid rain? No. In the case of the acid rain, also, which you find in prominence or somewhere in the news stories, basically you have the normal cloud formation, but the raindrops which occur, those raindrops, they interact with the nitric acid and basically the presence of nitrates and sulfates into the air. And those sulfates, when they interact with water, they form a dilute sulfuric acid. Nitrates, when they interact with the raindrops, they form a dilute nitric acid. So the raindrops which fall as a result of that, after encountering those pollutants, they basically are slightly acidic in nature. That is acid rain. Acid rain does not mean that the clouds are so acidic. If there is an airplane flowing or flying between them, the airplane will simply evaporate because it is acidic. No. Acid rain is merely raindrops combining with nitrates and sulfates, forming nitric acid and sulfuric acid. So it can be any kind of rainfall can create the acid rain. Is that understood? And Gaurav, what type of rainfall North India receives? North India receives a variety of or rainfall due to variety of conditions. Most of the rainfall caused is orographic in nature, majority of it, but some portion of it also receives cyclonic rainfall during the monsoon and frontal rainfall during the winter season. So North India also receives variety of rainfall due to variety of conditions. Early morning at around after 12 a.m. Which kind of rainfalls happen in these? See, generally the rainfall which is caused, it is not as if that in Bangalore today you had convectional rainfall, tomorrow you will have orographic rainfall, day after tomorrow you will have frontal rainfall. No. The how is it that the cloud formation is taking place? That is the point that you have to keep in mind. Once the cloud formation has taken place, after that, depending upon the air temperature, depending upon the moisture content and relative humidity, rainfall can happen at 12 a.m, it can happen at 5 p.m in the evening, it can happen 11 a.m in the morning. So but mostly the rainfall which is received in majority of the parts of the country, that is because of some or the other orographic barrier, or in certain cases absolute low pressure which is created on the ground, which will attract winds from all different areas, and those winds, whatever amount of moisture is present in them, that will rise up and that will lead to cloud formation. Now we come to the portion of frontal or cyclonic rainfall. Now, cyclonic rainfall is something which is not always associated with a occurrence of a cyclone, but the occurrence of a low pressure. We'll take a look at it, but very briefly, frontal rainfall. So immediately in the next module, we shall be discussing what do we mean by a front, how is it that a front gets created. But if you recall what we have studied in the portion of frontal inversion, you would have come across a scenario where when we say a front or when we talk about a front, we basically are talking about a region where the cold air and the warm air, they end up interacting with each other. You have the cold air and the warm air, which ends up interacting with each other. So what happens is when they interact, when they are moving towards each other, let's suppose the cold air is moving towards the region of the warm air. Now, it will not readily mix with the warm air and form a kind of a homogeneous mixture, because this cold air is basically the air extent that we are talking about can span for hundreds and thousands of kilometers. So you cannot have the air all across northern Europe mixing with the warm air and forming a very happy-go-lucky homogeneous mixture. No. Cold air will retain its property of being heavy, slightly compressed, and hugging closer to the ground. Warm air will retain its property of being lighter and having a higher amount of energy. So if maybe the warm air is moving towards cold air or the cold air is moving towards warm air, the warm air gets uplifted, right? And the warm air always touches the boundary of the region of the cold air. Now, as the warm air touches the boundary of the region of the cold air, its temperature drops. It can reach saturation. The warm air can reach saturation. And eventually, it can, if it gets cooled beyond that, it can lead to condensation and cloud formation to happen in this area at the boundary between cold and warm air. So here, that cloud formation can bring about rains as well. So basically, warm air in contact with the cold air loses its temperature, okay, and forms, undergoes condensation, causing rainfall. Okay, causing rainfall, or in general, rains. So that is the occurrence that you observe. Then cyclonic. So generally where you have a lot of frontal formation and the frontal formation getting exaggerated, you have the occurrence of certain types of cyclones also, which we will talk about in the next module. But here, when we talk about cyclonic rainfall, so in India also, especially in the northern portion and central India, substantial amount of rain is received because of this. Cyclonic rainfall does not always refer to the existence of cyclones. Obviously, it also refers to where you have the formation of cyclones, there rainfall can occur. But generally, it talks about rainfall created due to absolute low pressure conditions on the ground surface. So, basically, means rains during a cyclone, a cyclone, or absolute low pressure, extreme low pressure on the ground, attracting winds, okay. And what happens generally in the region around low pressure, where you have absolute low pressure, as we have seen even during the case of the cloud burst or the hailstorm activities? Let's suppose this is a region of low pressure. So as winds from all directions they come by, these winds eventually will also get heated up, will rise up. So there the winds they get attracted to the low pressure and they are risen up, they are forced upwards. Now as they start rising up, they will immediately start losing temperature, and when they end up losing temperature, they will lead to cloud formation and creation of and occurrence of rains. Okay, winds rises up, cloud formation, and rains. So what happens in India during the monsoon months is also sometimes attributed, the rainfall received in many parts of the country, that is attributable to the cyclonic rainfall as well. Because in India, what do you have? In general, if I give you an overview, okay, just a brief overview. I understand that right now you will not be able to understand it completely or appreciate it fully, because we have not covered either the formation of the cyclone, we have not covered the basics of monsoon, etc. So just think about it as a kind of a brief introduction to that particular aspect of monsoon. So in India during the monsoon months, during monsoons, some part of the country they will receive convectional rainfall. Some parts of majority of the parts of the country they will end up receiving rainfall due to orographic factor, and certain parts they will receive rainfall due to cyclonic factor. So what actually ends up happening is, if let's suppose this is the peninsular part of the country and this is your subcontinent, the entirety of the region of the subcontinent, or if you consider only India. So during the monsoonal season, as you would be aware, that there is substantial amount of heating which is created. Low pressure centers are in existence due to that heating. Okay. Now these low pressure centers, they will be attracting winds from all different directions. So winds will be attracted from here also, winds will be attracted from here also, through the Rift Valley system of Narmada and Tapi, that is between the Vindhyas and Satpura. Winds will be attracted from here also. Now all these winds, they will rise up upon reaching the low pressure. They will form dense clouds and they can cause rainfall. Cyclonic rainfall also is associated with the formation of the cumulonimbus clouds. Okay, so you have cyclonic rainfall, rains are also associated with cumulonimbus cloud formation. Okay, now Priya, does orographic rainfall can show a condition where we observe one side to be much more green due to rainfall, the other side dry because of warm air? So do we observe orographic rainfall? See, when we say, Priya, that the other side is dry, so this image is just a depiction of it. Mountains never will give you that kind of an image that one side it is very green, other side it is barren and dry. For example, in the region of Uttarakhand that you are talking about, here understand that anyways, if there is lot of rainfall, some amount of majority of that rainfall will occur on this particular side. And if let's suppose there is a mountain on the other side as well, here also if there is a mountain, then the rainfall caused in the middle region, that will end up giving moisture to both the areas. And anyways, the moisture availability in that region will be so significant that you will have some greenery available on both sides of the mountain. So it won't be an absolutely barren one. Okay. Akshay, which type of rainfall is received by Cherrapunji? Mawsynram is the region of highest rainfall received in the country and in the world, which is very close to Cherrapunji. Mawsynram and Cherrapunji, they experience what is the orographic rainfall. And after Mawsynram and Cherrapunji, the second highest rainfall receiving region in India is where? Do we have any idea about it? Where is it that you have the second most highest rainfall receiving region in India and in fact across the world as well, after Mawsynram and Cherrapunji? Let me see. No, it is not Arunachal. It is basically the region of Agumbe in the area of the Western Ghats, the western side of Western Ghats. Very good, Apurva. So that is where you receive very high amount of rain. So that also is because of orographic conditions. Because when you talk about the Western Ghats, they are not hills, they are not mountains, they are escarpments. Remember the folding and faulting? So when the winds come to this area, in the region of the western side of the region or the western side of the country, they experience a vertical wall-like formation or a structure in the form of Western Ghats. So the winds, they are suddenly forced to rise up almost vertically. That is why even the western part of the Western Ghats, they end up receiving substantially very high amount of rainfall. Agumbe is in Karnataka. Okay, Agumbe. Locate that place. A very good place to trek and a very good place to go for a ride in general. If ever you get an opportunity, you should absolutely avail that. Okay, so that is how you have the classification of different types of rainfall based upon how the cloud formation is observed. Okay, so the cloud formation can be observed by evaporation. Mind you, sometimes in certain areas, even due to evaporation, even during evaporation, you can have the cirrus cloud formed as well. So that depends upon the fact that what is the humidity, the relative humidity, because cloud formation will happen only after the relative humidity has reached 100% and is cooled beyond that. Only then will you experience a cloud formation. Otherwise, you won't experience cloud formation at all. So in the quest of reaching that relative humidity of 100% and cooling beyond that, many of the times the air has to travel 6 kilometers, 8 kilometers, 10 kilometers above the ground surface. So that is when you have the cirrus cloud formation also. Okay. Now, after this, we come to the formation of fog. Now, if you read the definition, if you take a look at the definition of fog mentioned everywhere, it will give you an idea that it is a kind of a cloud which is formed but at the ground surface. That is not very clear, right? So if you simplify it, fog is simply condensation happening at the ground level. Okay, condensation which happens at the ground level, that is fog. Now, remember, I had told you that condensation can never happen without a surface. Condensation will always happen when there is a surface in contact. So how does the fog formation take place? What is the surface which is provided? It is basically the prevalence of the dust particles. The dust particles which are present around the air around us, it is on that surface of the dust particles where that condensation takes place. Okay, so condensation taking place at the ground surface. Occurring at the ground surface. Okay, that is basically your fog formation. And this can happen when? Happens when the air near the ground loses temperature or cools down. Okay, it loses temperature. Eventually, after that, when it becomes cooler, when it significantly loses temperature, reaches saturation. And cools down and condenses into liquid water droplets. Okay, that is the entire process of fog formation. Now, depending upon how is it or why is it that the air close to the ground surface, why is it losing temperature? Based upon that, you have a general classification of fog into the types: upslope fog, advection fog, steam fog, surface fog, or radiation fog. You have the classification of fog into different types based upon how is it that the air close to the ground surface is losing temperature. Why is it that the air close to the ground surface is losing its temperature? So a fog is a cloud with its base at or very near to the ground, or a cloud that simply touches the ground. That's it. Okay, it shows up when the water vapor or water in its gaseous form, it condenses into liquid water droplets. That is what you observe in the case of fog formation. Okay, now there is also something that you come across, what is referred to as a mist, right? Now mist is also similar in its formation. The only difference between mist and fog is that the mist contains more moisture than fog. How? So each of the condensates, each of the droplet that is created during the time of the mist is having a thicker layer of moisture. So for example, in fog, let's assume that you have the water droplets condensing, the liquid water droplets basically condensing out. Okay. Now, in case that there is a mist formation, each of these will be much larger. Liquid water droplets will be much more larger. So that is what you observe in the case of mist formation. That is the only difference. The formation is almost similar. Okay. Now let us take a look at the classification of fog, the types of fog. And this types of fog, or the classification, as I told you, is purely dependent upon how is it that the air loses temperature. Classification based upon how the air near the ground surface loses temperature. Okay, that is what you have as the types of fog. And that is the basis for the classification of types of fog. Just like we had seen the types of inversion, that how is it that the inversion is taking place? Based upon that, you had the classification as surface inversion, subsidence inversion, valley inversion, frontal inversion. All of these processes were different, but the end point or the end result was the same: temperature inversion. Here also, the process of formation of fog in each of these cases is different, but the basic process followed by each one of them is going to remain one and the same. So you have the classification as radiation fog, advection fog, upslope fog, steam fog, and valley fog. Now, let us take a look at each one of them. Radiation fog. Now, here, the air has to cool down near the ground surface. So, for the air to cool down, the planet generally during the night time, the surface releases significant amount of heat in the form of what is referred to as terrestrial radiation. So that terrestrial radiation is quite a significant factor for the surface losing the heat. Okay. And when the surface loses heat, the air above it also cools down. And that is how condensation happens. That is the radiation fog is the one that you observe in our country, majorly, especially in the regions to the north of Tropic of Cancer. You will observe this kind of fog happening early in the mornings, right, or late at nights. It happens because the ground loses heat due to terrestrial radiation. So, due to the ground losing heat because of terrestrial radiation. Okay. Now, what are the conditions required for the ground to lose heat so suddenly because of terrestrial radiation that it will cool the air as well? So, long winter nights, right? When you have very long winter nights, the ground will lose heat very quickly. Let's suppose you have cloud formation. Now, in the presence of clouds, the clouds will re-radiate the heat back to the ground surface, heating the ground surface again, right? So, a clear, long winter night. That is the condition which is required. So, conditions required of what? Ground surface, or basically loses heat quickly. And when does that happen? When you have long winter nights and clear sky, lack of clouds. Why? Because in case there is a cloud formation, let's suppose there is a cloud formation here, then that terrestrial radiation will be reflected back and will reheat the ground surface. But here you need the ground surface to cool down. So that is why clear sky is required. That is why nights during the clear skied nights are much cooler in comparison than the cloudy nights. Cloudy nights generally they are associated with some humid and warm conditions. Clear skied nights are generally colder. So that is the condition required. So what happens is that during the night time, the ground surface continues to lose the heat by the terrestrial radiation. Okay. terrestrial radiation. Now, what this terrestrial radiation does, it makes the ground surface colder, and when the ground surface becomes colder, the air above it also becomes colder. Air also becomes very cold because it is in contact with the ground surface. And when the air starts dropping its temperature, that is when it shall attain what we refer to as condensation, and it's, or rather before that, saturation, and eventually after saturation, condensation will be observed. And at that point of time, we will observe the formation of fog very close to the ground surface. Now, when does this fog dissipate, or how does this fog disappear? Generally, you would have observed, in case you have observed the fog formation, you would have observed that next morning around 6 a.m., 7 a.m., when the sun starts shining back again, then the fog dissipates from bottoms up, in the sense that the sunshine will heat the ground surface, and then the air above it will also heat up. Now, we do know that an air, when you heat it up, any air parcel, when you heat it up, what happens to its relative humidity? Upon heating of the air parcel, does the relative humidity increase or decrease? What do we think? Upon heating of the air parcel, does the relative humidity increase or does the relative humidity decrease? Beautiful. The relative humidity upon heating reduces, right? So relative humidity decrease. If the relative humidity overall decreases, means what? Means the air can take in much more amount of vapor. So that is how the fog eventually will dissipate. So the fog dissipates early next morning upon receiving heat from the sun, where the ground surface heats up, and then the fog dissipates from the bottom region upwards. Okay, so fog next morning, ground heats up, heating the air above, and that means leads to dissipation of fog from bottom upwards. Okay, so that is how next morning, after a couple of hours of sunshine, the fog completely disappears. Something that you would already will observe in the next couple of weeks in many parts of the country, especially in the northern India. Okay, so this is the radiation fog. Now, then you have advection fog. Advection basically talks about the horizontal wind movement, right? Now we have two different types of advection: cold advection, warm advection. Now, whenever you have the presence of an advection, it can happen that warm air moves over to the colder surface, right? What is the warm advection in general? So warm air moves towards the colder surface. The warm air gets in contact with the cold surface, right? So when we talk about warm air advection, so you have warm air moving over a colder surface. The warm air loses temperature, cools down, reaches saturation, leads to formation of fog, And that fog which is created purely because of that process of advection. Hence, it is also what is referred to as the advection fog. Okay, that is generally observed in this scenario, in this case. Okay, previous slide. Okay, this is the previous slide. This is about the radiation fog. Then we have seen the fog formation happening because of the process of advection. And then I hope this is done. Okay. Now, after this, we move towards what is referred to as the steam fog. Now, the name steam fog, that name is ascribable because of how the fog appears to look like. If you take a look at this particular fog formation, you would observe basically it gives you an appearance as if steam is rising from the water surface. Steam rises at a very high temperature. So obviously there is no steam happening here. But the fog gives you the appearance of a rising column of air. So when does that happen? So this happens when cold and dry air moves over warmer water. So late at night, early in the morning, when the ground has cooled down quite significantly, but the nearby water body is comparatively warmer. Okay, so late at night and early in the morning, or very early mornings, basically, in this situation, water is warmer, land is very cold. Movement of air from land to water. So those of you who are living in areas, or if you have ever visited those large dams and reservoirs and the large water bodies across the country early in the morning, or if you reside in that area, you would have experienced this kind of a fog formation where early morning when you wake up, the land areas, they are particularly clear, but wherever you have the water, there it gives you an appearance of a foggy formation. So that is your steam fog. So how does it get created? So basically, understand here, let's suppose there is water body and nearby you have the land area. So in this case, by the way, guys, this is, yes, this will be observed over rivers also, if the rivers are very, very broad. So for example, River Ganga, River Yamuna, River Kaveri, Godavari, Brahmaputra in the plain areas, right? So in those areas also, you will observe this wherever the river is substantially wider. So what happens? Here, one thing that you have to keep in mind is that water is comparatively warmer. Water will always continue to give rise to evaporation, right? So some amount of water vapor will continue to be lost or continue to be moving upwards due to the process of evaporation. Gaurav, is steam fog can be observed on small ponds also? Yes. So not very small in the sense that you can move around it within 5 minutes, but if it is slightly bigger, it will, where the water can have its own individual temperature property. See, if the water body is very, very small, right, in the sense that you can run through it, the water will not have its own independent temperature characteristic. If the water body is slightly larger, it can begin to exhibit its temperature characteristics, so you would be able to observe that. So in rural areas, yes, you would observe that as well. Okay, Akshay, it happens in ponds as well, as I have seen in village. Yes, definitely, yes. So here, water is lost in the rising columns of air due to evaporation. That is a continuous movement. Now, meanwhile, you have very cold air coming from the region of the ground surface, land surface, over the water body. Now, this is your very cold and dry air. Okay. Now, as it encounters this water vapor, think about the fate of the water vapor. So, water vapor is present, that is, water in its gaseous form is present, and suddenly you have very cold wind coming over. So, what happens? Immediately it will start condensing, right? So, that is where the condensation happens in this area after getting in contact with the cold air. So, in this entire region, the water vapor condenses, vapor condenses after getting in contact with cold air. This condensed form of water vapor will always give you an appearance, and many of you have noticed this in your own lives on a day-to-day basis. Many of you have noticed this. So if you recall that memory, if you recall that particular instance where you had observed this, you would observe that it doesn't have a kind of a fixed level. For example, in the case of radiation fog, when taken a view from a far off place or a distance, it always gives you a flattish appearance from top, right? Something which is hugging the ground surface in the form of a kind of a layer. But when you talk about the steam fog, it will have a distorted appearance. It gives you an appearance as if it is rising up, whereas it is not, right? It is simply condensation. So, right? So that leads to formation of steam fog. When will that get dissipated? Next morning, again, as the land surface heats up, the water body heats up, then again, you will have the dissipation of the fog. I hope that is understood. Now, moving on to the next type of fog, which is basically your upslope fog. Upslope means upwards in the slope. This is also because of very slow movement. So, remember, I had told you that the wind speed can vary quite significantly. Wind speed, when it is very slow, it is referred to as a breeze. Wind speed, when it is fast enough, it is referred to as a wind in many cases, gale, storm, etc. Now, when you have a slower wind speed, in that situation, when we refer to it as a breeze of sorts, when it slowly and steadily rises up the slope, right? So, there also, it will start losing temperature, obviously because of height. Now, this is a very slow movement. If there would have been a fast movement of wind and the slope would have been steeper, it would have led to the cloud formation. But here, the slope is also not very high. It is generally gentle in terms of its slant, and also the wind movement is slow. So it condenses along the way of that slope. So that is why all along the slope, you will observe that condensation happening, and you will observe the fog formation in that entire area. So that is your upslope fog. So basically, upslope fog or hail fog forms when the winds blow air up a slope. What is orographic uplift? So as the winds slowly rise over the slope, gradual loss of temperature is observed, and that gradual loss of temperature means gradual rate of condensation. That means in one place, all that condensates won't concentrate. It will be spread over to the slope. So if ever you have trekked across hills in the morning, you would observe that foggy condition where slowly and steadily, as you huff and pant your way to the hilltop, by that point of time, the fog gets cleared up in many of the cases. Right. So those of you living in hilly areas would observe it on a daily occurrence, somewhere early in the morning. Tulsi, in which season this will happen more? Are you talking about the upslope or the steam fog? Because if you're talking about steam fog, generally winter mornings, early winter mornings is when you observe that steam fog in very significant prominence. Sometimes even during the rains, when there is substantial amount of rainfall, because the humidity level is so very high, fog formation is easier in that case. Okay. Now, then after that, we have the valley fog. Now, the process of formation of a valley fog is very similar to what you have studied as a case of valley inversion, almost very similar to that, right? So here you have the same process which is observed in the valleys, of the mountains between the slopes during night as the cold air from mountain top starts to sink. Okay, so what happens? For example, let's suppose I have a mountain top here. I have another mountain top in this region. Now, during night time, you will have cold air on top of it and warm air at the valley bottom and cold air at the mountain top. Now, that cold air simply sinks because it is heavier. Down the slope, the cold air will start sinking and it will replace the warm air from the bottom. The warm air will get lifted up, causing temperature inversion or valley inversion at the valley bottom. But here, think about it, that this entire region of warm air that is in contact with cold air from the sides. So that is why there will be condensation happening in the entire region wherever the warm air is in contact with the colder air region. That is why in the valleys, late at night, early morning, the visibility is completely out of the picture. That is the reason why in the region of Sikkim, in the region of Uttarakhand, in the region of parts of Himachal, parts of Ladakh, parts of Arunachal, you will have even the Air Force, which operates at these high altitudes. They do not fly the helicopters in these areas after, in certain cases, after 1 p.m., in certain cases, after 2 p.m. itself, in certain cases, definitely beyond 3 p.m. or 4 p.m., they will never fly in that area. Why? Because the visibility becomes so very distorted, the valley in itself is not at all visible. You won't be aware in the sitting in the helicopter where you have certain protrusions in the form of small mountains, etc. Remember the sad accident which happened a couple of years back in 2021, where we lost our first CDS, the Chief of Defense Staff, General Bipin Rawat. I hope you recall that we lost him due to a helicopter crash, where he and his wife, along with certain number of defense personnel, they were lost in the helicopter crash in the region between Wellington and Kannur, in the area around Tamil Nadu. Now that also happened. Why? That was because of valley fog. And valley fog basically means that if you are, let's suppose your helicopter or your chopper is flying here or here, you have no clue about the depth nearby, right? That is why oftentimes it leads to significant amount of accidents which have occurred in Arunachal also, where also we have lost dignitaries, and in the region of Tamil Nadu also, because there also you have the similar feature. So the warm air at the valley bottom, as soon as it gets in contact with the colder air around, that colder air can be brought about by rainfall, condensation in general, low temperature. It absolutely inhibits the visibility, and that is what leads many of the choppers directly hitting the slope with high speed. No chance of survival in that case. Okay, so the next time when you encounter such kind of sad events, when you observe these sad events, apply your logic. Why would this have happened? For Air Force pilots which have been trained so substantially well, which know the terrain so significantly well, why is it that still those accidents happen? Because of the visibility factor. Okay. Now, what about the sonar in helicopter? See, the sonar device that is present in helicopter, it will give you an idea about the ground clearance, right? So think about it and apply your logic for that brief moment. Suppose your chopper is flying at this particular height. It will give you an idea that, and chopper, it is not as if it is stable at the same place for a long time. It is also moving with a substantial speed, right? So it is moving here. It is showing you that the depth is significant and is sufficient, and within a few seconds you have moved here. It is showing that the depth has started reducing, right? And many of the times the computation of that depth, that is so very sudden. Before you can change your direction, you will encounter the trees on top of these hills, mountains, etc. And maybe a tree in this region is where you can have your wing or any part of your chopper entangling immediately. That will lead to a crash. Okay, I hope you understand the overall scenario. Out of five, which one is more impacting on the visibility? See, the visibility reduction in upslope fog is the minimum. It depends upon what is the level at which, or what is the amount of condensation which is happening. Because advection fog, advection fog sometimes is also created across. When we read about ocean currents, maybe tomorrow you will have a better clue about it, that you have warm and cold oceanic waters mixing with each other in certain places. So warm air and cold air will get in contact, but because we are talking about oceans, the moisture presence is so high, visibility is almost stopped, right? So that also leads to navigation disasters. For example, Titanic, all the most prolific sea or maritime disaster that one knows of. So that also visibility is reduced. So sometimes, so that is also a process of advection. So radiation fog, we all know, it also substantially reduces the visibility. Those of you who have had to travel during the night in the region around Delhi NCR, you would be aware, or in any parts of the northern India during the night, you would be aware of how dangerous it is, because you won't be able to see 10 meters in front of you. So it all depends upon what is the rate of condensation, where it is happening. Okay. Now, why it happens that after a rainfall, mountains and trees look like super crystal clear? Because of all the dust particles, etc., removed, and the cloud and whatever humidity is present in the air, that is also taken away. So that is why everything appears to be clearer. But within a couple of hours immediately after that, after heavy rainfall, you observe the development of mist around that entire region. Okay. Akshay, was it a terrorist planned death or a sudden accident? It was a sad accident which happened, and it was basically, the reports also indicated upon study of the various equipments, that the pilot basically eventually they get disoriented, and these were the, if you are a pilot who is carrying the chief of defense staff, obviously you are very well accomplished in your job, right? And you are having many more trained hours under your belt. So think about the level of fog and the level of disorientation which would have resulted in this disaster. Okay. Now, after this, let us have these certain questions which have been asked in the prelims examination. What causes the wind to deflect to the left in the southern hemisphere? Temperature, magnetic field, rotation of the earth, and pressure. Does steam fog happen in oceanic areas? Yes. In certain areas, yes. Correct, Madhuri. Parshuram, incorrect. Shahid, correct. Beautiful. Majority of you have given the correct answer. So, what causes the wind to deflect to the left in southern hemisphere? It is the Coriolis force. Coriolis force. And this Coriolis force is an apparent force which is observed in the northern as well as in the southern hemisphere. Why? Because of the rotation of the planet. Had the planet not been rotating, Coriolis force would never have been in existence. So, rotation of the Earth is the answer of this. Then, westerlies in the southern hemisphere are stronger and more persistent than in the northern hemisphere. Why? Southern hemisphere has less landmass as compared to the northern hemisphere. Coriolis force is higher in the southern hemisphere as compared to the northern hemisphere. Why is it that the westerlies in the southern hemisphere, they are much more prominent? Correct. Madhuri, Shahid, correct. Sherlin Usna, correct. Good. So more number of people are giving the correct answer, which is encouraging. So westerlies in the southern hemisphere are more stronger. Remember, we had talked about the fact that in the southern hemisphere, because you have more predominance of water bodies, the force of resistance of the frictional force is very, very less. And because the frictional force is less, that is why you have the winds moving very fast in the southern hemisphere. Westerlies, they are given the name of furious 40s, fury 50s, shrieking 60s, right? Because of the sound and the howling sound that they make as they move with a very strong velocity. So it is primarily because of lesser resistance, primarily because it is dominant with the water body. So this is correct. Coriolis force is equivalent in the northern and the southern hemisphere. Speed of westerlies is not impacted by Coriolis force, and the predominance of westerlies is not at all impacted by the Coriolis force. Coriolis force impacts the wind direction. After it has gained the speed, the direction is impacted by the Coriolis force, but the speed is not impacted by Coriolis force at all. So the correct answer is going to be A, that is one only. Okay. Then this is a question that we had already discussed. I hope we don't have any doubt in that. And a layer in atmosphere called ionosphere facilitates radio communication. Why? We had discussed this question, right? I hope that is clear. Or do we need to launch a poll for this as well? No. Good. So in this, the answer was neither one nor two. Ionosphere facilitates radio communication because of the presence of charged particles in the ionosphere, which will reflect the radio waves. And a jet aircraft flies very smoothly in the lower stratosphere. This question also we have discussed. Now we move on to the next topic, a very important module for the point of view of your examination, both prelims as well as mains, that is air masses and cyclones. Before that, do you need a break or do we continue with this? Please let me know. Okay. Okay, fair enough. I have 4 people telling me to continue and rest of you telling me to take a break. So, okay, we'll do one thing. We'll take a break and we'll get it out of the way. And then, how long a break do you guys need? 10 minutes should be more than sufficient, I guess, because we have just initiated the discussion. So 10 minutes break you take, refresh yourself up. Then we will extend the session till around 3:15. So lunch break will be slightly after a certain delay. So take a break for 10 minutes, refresh yourself, get back. We will start the discussion about air masses and cyclone. Okay. Confirmation about the audio, please. The audio is clear and available. Kindly confirm. Thank you. So now we move to the portion of air masses and cyclones. First of all, let us understand that this particular area is relevant both for your prelims as well as for your mains examination. Okay. So here, what is the area which is relevant for your prelims? So in your prelims, generally, if you take a look at the trends of the questions being asked in the prelims from geography, you will find questions associated with cyclones, basics of cyclones, their formation, conditions required, frontal formation of front, warm and cold front. But this is not very frequented. Frontal formation is not very frequented by UPSC, but there have been questions which have been asked previously. Warm and cold fronts. Okay. And then in the mains, you will be frequented by questions being framed from the region of, again, air masses and their impact, fronts, formation and their types, cyclones. Here, mostly tropical cyclones are asked, formation, as well as naming. But you should be aware of the temperate cyclones also, and you should basically give due attention to the temperate cyclones also, because that can also be asked. But naming of cyclones, what is the process of naming, that is asked, right? Many of the candidates, what they do is they try and start learning the names of the cyclones which have been occurring for the past year and a half, but that is not something which is required for civil services. Okay, so only the formation and naming is where you have to stick on to it, and we will study these in significant detail. So in this particular chapter or module, we shall be discussing what do we mean by an air mass, how is it that a front gets created, what is the naming of the air mass, the different types of air masses which are in existence, then the different types of fronts which get created, the associated weather patterns with each of the front, in which regions of the world do you experience frontal formation, and then from that we shall basically be graduating into the occurrence of cyclones. What do we mean by a cyclonic event, what do we mean by an anticyclone, then what are the different types of cyclone, that is the tropical cyclone and the temperate cyclone. Obviously there is a stark difference between them, and temperate cyclone in its process of formation itself is very different from that of a tropical one, and the destruction caused by a tropical one is much larger, much higher. What is a tropical cyclone, its formation? What is a temperate cyclone, its various stages of formation? What is known as bomb cyclone or explosive cyclogenesis? Which is the season when we are frequented with cyclones? All those factors we are going to study here. IMD announced that there may be a cyclone in Arabian Sea named Tej. Yes, and IMD also announced that next week, that is in the next 10 days, you might have another cyclonic formation in the region of Bay of Bengal. And that is because we are hitting the cyclonic season. Cyclonic season in India is in existence generally in the last week of April, in the month of May, rarely in the or sometimes in the month of June, first week of June, but that's it. And then the cyclonic season comes in the month of November, and December. That is where we experience cyclones emerging in the region of Bay of Bengal and Arabian Sea. Why only these months? We will discuss it when we discuss the Indian climate and Indian monsoon. Okay. So let us initiate the discussion with air masses. Air mass, in simple translation, in simple interpretation, mass of air. That is what is an air mass. Okay. A large mass of air, that is an air mass. Now, when we talk about an air mass or a large mass of air, what are we referring to here? So, if let's suppose over your city, whichever city, let's suppose Bhopal in Madhya Pradesh, over your city you have a large chunk of air. Can that be referred to as an air mass? The air present over Delhi, can we refer to that as an air mass? No. When we consider masses of air, we are considering air in the proportions much larger than a few cities in existence. We are talking about a continuous air formation or the presence of air in a continuous region for more than 100 kilometers, 1000 kilometers, etc. But here the immediate argument which can come from your side will be that air is present all across the planet. So how do we distinguish that this is an air mass, this is not? So when you have an air parcel or any sample of air which spreads over a very large area and has got basic homogeneous properties, that the temperature is consistent throughout that region, air temperature, moisture is consistent throughout that area, the humidity. So then that air parcel which spreads over that large distance can be considered to be behaving like a mass of air. And that is what is referred to as an air mass. So when you talk about air masses, the air with distinctive characteristic in terms of temperature and humidity is called an air mass. It can spread for hundreds and thousands of kilometers in its dimensions. Okay, can spread over hundreds of kilometers in terms of dimension. That is what is an air mass. Okay. So when the air, actually when we say that the air has got a property of temperature, that the air temperature is, let's suppose, 27 degrees Celsius. Humidity is, let's suppose, at 80% or 60%. Now, where does that air gain that property from? Obviously from the ground surface. So when the air remains in one region for a longer period of time, it starts attaining the property of that region. For example, if you recall your from your childhood memories, if ever you would have visited the coastal area or a region very close to a river bank, you would have observed that the air has slightly different property. Not so much across a bank, but across a coastal area, the air would have been very humid. Whereas when you go to visit any areas in the, let's suppose, interior of the peninsular part of India or significantly in the northern part of India, the air would have been very dry, right? So depending upon what the ground conditions are, what the ground realities are, the features of the ground are, the air property can be very different. So when the air remains over a homogeneous area for a substantially longer time, it acquires the characteristic of that particular area. When you think about the regions such as India, now in India, starting from the southern part of the country, you would observe that very close to the coastline or in between the coastline, you don't have much of a distance, right? So in southern part of the country, let's suppose we talk about the region around Karnataka, Tamil Nadu. Now, coastal area, different air property. Then Western Ghats, air property is going to be different. Then again, Eastern Ghats, air property is going to be different. Then again, Bay of Bengal, condition is going to be different. When you come to the portion of Central India, again, across the coastal region, air property is going to be different. Near the hills and the mountains, air property is going to be different. In the region of the plateaus, the air property is going to be different. If there are plains and forests in between, air property is going to be different. And again comes the coastal area. In the northern part of the country, in the mountains, air property is going to be different. In the plains, the air property is going to be different. So, and when you talk about the western part of the country, desert, air property is going to be different. So, in India, across the larger spectrum, you won't observe that you have one kind of air having a homogeneous form of temperature, homogeneous form of humidity or moisture presence. So, when we talk about air masses, we are talking about very large aerial coverage. Now, the region on the ground from which they gain their property of temperature and humidity and so on, that region is what is referred to as the source region. It is that source region from which the air will gain its properties. So, source region, when you talk about, before looking at the written text, I want you to identify with these three images. For example, in the first image, it is clearly a desert. So we can think about it that the air will be dry, right? If it is a warm desert, the air will be hot and dry. That will be a property in that area, right? But why? Because the air is in contact with that ground surface, which is also hot and dry. Then, if you talk about the polar areas, air will be very, very cold. Then, when we talk about the tropical water bodies, that is ocean, seas, etc., air will be moist, very moist. Humidity presence will be very high. But all these properties of air that we are talking about are purely because of the property of the source regions, the property of the surface. So that property of the surface is attributed to the air also. Okay. So the areas over which the air masses originate or form are called source regions, whose nature and properties largely determine the temperature and moisture characteristic of the air masses. Okay. So that is how, based upon the source region and its interaction with the source region, the air masses will gain their own properties. Now, the naming of air masses. How do we go about and how do we name these air masses? Now, basically, we understand that depending upon the source region, the characteristic of the air mass will be different. So, we do know that the air mass over the water body, that is the oceans and seas, that will have a different property as compared to air masses over the continents. Air masses over oceans will be much greater or much higher in moisture level, whereas air masses over the larger continental areas, they will be much more drier, right? Air masses over the region of Arctic will have a different property as compared to air masses in the tropics. Air masses in the polar area or the region of Siberia, Canada, they will have a different property as compared to the air mass over Atlantic. So the naming of the air masses is done based upon the regions where you have the air parcels indicating a uniform property. So how is that naming done? So first of all, one needs to identify whether the air mass is continental or maritime in its nature. If it is continental, it will be dry. If it is maritime, that it is in existence over the seas and the oceans, it will have a very high moisture level. So that is why in the naming also, the first letter that you denote for an air mass is a C or an M. Both of them represent whether it is continental or maritime. So for example, here, first naming that is done is basically C represents continental, which generally ends up becoming drier because obviously continental regions no source for availability of moisture, so that is why it will be drier. And M representing maritime over the oceans, right? Don't think about it that river bodies also will have maritime air mass. No, they are too very small and negligible in order to shape the property of the air parcel in that area. So oceans, they are moist. significantly moist in nature. So that is how you have C and M. Now, that is a prerequisite, preliminary requirement. After that, depending upon which region the air mass is in, that is the latitudinal extent, the air will gain a property of being colder, warmer, and so on. For example, in the equatorial areas, you attach the letter E, right? So you have ME. That means it represents what? It will represent maritime equatorial. Okay. Then, for example, you have CT or MT, representing what? Continental tropical or maritime tropical? Continental tropical or maritime tropical? Right. Now, similarly, for the region of, I hope you can see this, for the region of Arctic, you attach the symbol A. That is in the region of the Arctic Ocean and the surrounding land masses that you have in the northern portion of Europe and Asia. So that will be your A. Excuse me. In the region of Antarctica, Antarctica is a continental landmass. So there, the symbol that will be associated will be AA. Then in the polar regions, that is, polar regions does not mean exactly the poles. For the region exactly at poles, you have either Arctic or Antarctic, which is used. Polar regions here basically refers to continents and oceans in the latitude between 50 to 60 degree north and south latitude. So that will be your P will be attached, right? So maritime polar, continental polar. So 50 to 60 degree north and south latitude, that is the higher latitudes. Then tropical, that is continents and oceans 20 to 35 degree to 40 degree north and south, and equatorial at the region at the equator. Here you will observe that in the naming of these air masses, there is no continental equatorial. Continental equatorial air mass does not exist. Equatorial does not exist. Why? Because when we talk about continental, so continental generally is associated with a drier condition. Continentality means the land area. So continental air mass is generally associated with dry condition. But around the equator, air is never dry. Why? Why is it that the air is always moist in the region around equator, even across continents? Think about it. Apply your logic. Good. Sherlin, Shahid, and Ravi. Good. Because around the region of equator, you have the presence of low pressure, which ends up creating some amount of convectional rainfall on a daily basis. Okay, so that is why even in the continents around the region of equator, on a daily basis in the evenings, late afternoons, you will receive convectional rainfall due to formation of cumulonimbus clouds through the day. So almost on a daily basis in the evening, because you have heavy rainfall, and in the daytime you have evaporation. So evaporation also means moisture supply into the air. Evaporation means from the ground surface the moisture is being supplied into the air immediately above. So what does that translate into? That air in the region around continents will never be dry. So will it have the continental property? No. Right? So that is why you will only find maritime equatorial, because maritime is associated with high moisture content. That is why around the region of equator, you will find only the presence of maritime equatorial, not continental equatorial. Is that clear? Is that understood why you don't have a continental equatorial? Because around the region of equator, air masses are never dry. It is always going to be moist. It is always good because continentality is always associated with low moisture content with the existence of dry air. Okay. So here, accordingly, you have the following types of air masses: maritime equatorial, maritime tropical, continental tropical, maritime polar, continental polar, continental arctic, that is around the region of Arctic, you have land masses, right? And then continental Antarctic. So, for example, if you take a look at the classification, the division of these air masses, you would come across maritime equatorial here around the region of equator, right? Around the region of equator, the islands that are present, all of them maritime equatorial, rainfall on a daily basis, air is significantly moist. Then as you move to the slightly mid latitudes, that is in the region of the tropics, you will come across in the continental areas also very dry air which is hot, right? So here also you will come across some continental tropical, not significantly uh, to that great extent. So here observe continental tropical, continental tropical. Then maritime tropical, water bodies nearby, maritime tropical. Okay, maritime tropical, all of them. Then after that, if you move further higher up in latitude, 50 to 60 degrees, remember that. So that is where you have maritime polar also. Maritime polar in both the hemispheres. Maritime polar. Then continental Antarctic. Then continental polar plus continental Arctic. That is a feature that you will observe. Okay, so that is why you will find you don't have continental equatorial. But here, one of the prime fears that the candidate face while looking at this denomination is that do we need to learn all of this? So the answer of it is both yes and no. Why it is a no? Because if you are required to learn this, that means you are not understanding anything in this case. First of all, UPSC is never going to ask you, bring forward the various denominations of the air masses across the world. That question UPSC is never going to ask. UPSC has got much better standards for it asking questions. So, UPSC might ask you about the air masses, its properties, and how the impact of it on climate. So here you have to think about it: equatorial, tropical, polar. These are the three regions, right? So in equatorial, you can only have maritime. In tropical, both maritime and continental. In polar also, both maritime as well as continental. So like that, you can not naturally and normally come at the deduction of it. Okay. Now, after this, once we have understood the air masses or looked at the existence of the various air masses, one needs to look forward much more significantly in this if you observe the boundary regions between warm and cold air. So, maritime polar is going to be cold, continental polar is also going to be cold air, right? And maritime tropical is going to be warm, and continental tropical is also going to be warm. So what if I were to draw a boundary line between the warm and the cold air? Now, as you can see, these particular set of lines, they will end up separating the warm and the cold air masses in both the hemisphere. Now, it is in these regions where the warm and the cold air masses, they will be confronting each other. But as you can observe from the image, that these are vast extensions of air masses which can extend for virtually hundreds of kilometers, right? So when you have that vast extent of air masses encountering each other, that is what leads to formation of a front. So what is a front? Front is an English terminology. Front is not a geographical terminology like a drumlin or sorts. Front is properly an English terminology. So when we talk about front, first things first, what comes to your mind? The end of something. You would have heard of sentences, he led the battle from the front. The army is posted at the front. So what does that tell you? Somewhere in the fringes, at the end of something. So when you have a situation where you have on one end the existence of a cold air mass, significantly cold air mass, and at the other end, let's suppose you have the presence of warm air mass. Now, that zone of difference between the property will be significantly larger as well. It will extend for a large distance. So that zone of transition, this is what is regarded as a front. Okay, this is what we refer to as a front. Again, let me repeat it. The general misconception or the general idea development which happens in the mind is that, okay, cold air is coming, warm air is coming. Cold air will give some property of it to the warm air will give some of its property to the cold air. They will mix, gain a uniform property, live happily ever after. But that is not how it works. This cold air can also have a movement. Basically, it does have a movement. Where is that cold air coming from? What do you think? If I say it has got some movement, where is that cold air virtually coming from? In terms of the pressure zones that we have studied. Good. Very good. Ganesh, Shahid, Abhishek, Ankit. Correct. Generally, the cold air is a product of the region of poles and the subpolar area. That is the area from which the cold air is coming from. And the warm air. This warm air, if it is coming towards the colder region, towards the subpolar area, where is that warm air coming from? What is the origin point of it in terms of the pressure zones? The warm air is coming from which area? No, not equator. Ankit, correct. Akshay, both warm and cold air, they are coming from the ground surface only. Madhuri, correct. Niranjan, no. Okay, not correct perfectly. This warm air is coming from the region of the subtropics, right? The subtropical highs, remember? That is the area from which the air moves to the subpolar region. So this warm air is coming from subtropics. This cold air is coming from the polar area. Now, they won't readily mix and interact with each other. They will form a zone of transition. So for example, let's suppose you are an individual standing here and then you decide to move and you come here. Now, in that transition, you are coming from a region of very cold area to a region to warm area. It is not the case that one of my leg is in the cold air region, other one of my leg is in the warm air region. This zone of transition is also going to extend for a few kilometers, tens of kilometers at least. So that is what is front. Now, frontal formation. The formation of a front will happen when? It will happen when the cold air and the warm air will meet. That process of generation of a front, creation of a front, birth of a front, that is what is referred to as frontogenesis. Genesis means creation. So that process of creation, when the warm air and the cold air, they come head to head in front of each other, that is frontogenesis. Okay. Now, the fronts are created where? If I take you back to this particular map, where are the fronts created? They are not created at the lower latitudes. Around the equator, they are not created. They are not created in the region of the poles. They are created in mid latitudes, where you have the cold air and the warm air. They end up meeting each other, isn't it? So that is why you will observe that frontogenesis is observed in mid latitudes and are demarcated by a sudden and a steep gradient in temperature and pressure of that area. Okay. Now, here, when you think about it, it can also be possible that over a period of time, Let's suppose that over a larger period of time of 2 weeks, 3 weeks, neither the cold air has moved towards the warm air, nor the warm air has moved towards the cold air. It can happen in certain cases. Now, if the air is warm air and cold air, they both are confronting each other in the same area, there will be some mixing which will take place. At the boundary region, some mixing will take place. Cold air will gain some heat, warm air will lose some heat. There will be mixing. Eventually, you can come across a situation where in the intervening area, in the transition area, you have an air of homogeneous property which develops after 20, 25 days or 28 days. Right? That is generally 3 to 4 weeks is the time window which is considered. In that 3 to 4 weeks, if there is no movement happening, the air which is in contact might gain each other's properties. So when the air becomes homogeneous, when you don't have sudden difference in temperature and pressure from one region to another, that is not a front anymore. Basically, whenever we say a front, in the case of a front, you have a sharp transition in temperature and pressure as you move from one region to the other. But if let's suppose they represent a uniformity, you cannot have that sharp transition anymore. So that is what is the death of a front. And that death of a front is the process which is referred to as frontolysis. So frontolysis refers to dissipation or death of a front. That is what is regarded as frontolysis. Okay, that is what we know as frontolysis. When does this happen? When eventually, after some time of being exposed towards each other, let's suppose that the air starts gaining each other's properties. That is what we regard as frontolysis. Till now, are we comfortable or have we got any doubt up till now? Comfortable? Good to go? Good. Now, after this, we talk about the types of front. Depending upon whether the cold air is active, whether the warm air is active, whether in case both of them are active or none of them are active, you have the classification of fronts into different types. Formation we have seen. Whenever you have warm and cold air confronting each other in the mid latitudes, that is where front formation will happen, right? Greater the temperature difference, greater will be the front formation. Temperature difference between what? Greater temperature difference between the warmer and the colder air, greater will be the chances of front formation or frontogenesis. So frontogenesis or formation of a front is more prominent when there is a greater temperature difference between the colder and warmer air. There is going to be a greater amount of temperature difference between them, right? Now, if you think about it, between the tropics and between the polar area, the temperature difference, because the colder air is generally coming from the polar area, warmer air is generally coming from the tropics and the subtropics, right? So greater the temperature difference between them, greater will be the chances of occurrence of fronts. So if I ask you, when is it that there is going to be a greater temperature difference between the polar and the tropical air? Is it going to be experienced in the summer season or in the winter season? What do you think will be the answer for that? When is it that you observe a greater temperature difference between polar and tropical air? Is it during the summer or is it during the winter? Madhuri summer, Parshuram winter, Meera summer, Ganesh Niranjan Shahid winter, Apurva winter. Okay. Okay. Let me tell you actually what happens. Is there any front having more than two air masses? No. On the ground surface, no. So here, let me tell you what actually happens. If you talk about that chart of winter, or rather we should go first with summer and then winter. Tropics, because that is where the warm air comes from, and also subpolar area. That is where the cold air is coming from. Now, generally in the tropics, I'm not talking about the extremities, but on an average, during the summer, the temperature is somewhere around 30-35 degrees Celsius on an average. If you consider extremities might be 45-46, but on an average, it can be taken as 30 to 35 degrees Celsius during the summer. 30 to 35 degrees Celsius, right? Whereas in the polar area, let's not talk about subpolar, let's talk about polar so that there is less amount of confusion. In the polar region, the summer temperature is warmer comparatively. It gains a temperature of close to around minus, it is still in negative territory. It is not going to be positive. It is not going to increase above the melting point. However, due to global warming, etc., the temperature at the poles also is rising, but it still remains in -5, -10, somewhere in that range, -15 also, somewhere in that range. So let's assume -10 to 15 degrees Celsius. Okay. Now, during the winter in the tropics, temperature drops. But temperature drops to what extent? 25 to 30 degrees Celsius? Right. I'm not talking about the regions such as Delhi, Northern Plains, etc. There you have very low temperature due to different conditions. But in general, across the tropics, the winter temperature is on an average during the day, even in Delhi, etc. The temperature that you experience is how much? Roughly in the range of 20s. So let's assume 25 degrees Celsius. What about the poles? In the poles, during the winter, the temperature is very, very low. Poles don't get sunlight during the winter. It is continuous night time. So the temperature drops to somewhere around -40, -45, isn't it? So let's consider -40 as in, or -45 in fact, because in certain cases in Antarctica, even in the region around Arctic, the temperature during the winter can dip to -50 also, -55 also, as has been observed. So here, difference in temperature in both the cases. So in the first case, what is the difference in temperature? All the bright minds who are going to ace the CSAT examination. What is the difference of temperature between the tropics and the poles? Good. It is somewhere around 40 to 45 degrees Celsius. Those of you who are saying 20 to 25 degrees Celsius, you need to revise your BODMAS rule of addition subtraction carefully, right? Because What you guys have done is 35 minus 10 or 30 minus 10, right? So that is something which you should take it up. Then in the winter, the difference in temperature comes out to be somewhere in the range of 60 to 70, right? So it is 70 degrees Celsius on an average. So the difference in temperature is going to be higher when? During the winter season. So that means frontogenesis in both the hemispheres will be much more frequently observed during the winter months. Okay, so most commonly observed during winter months. Okay, that is when you will observe that frontogenesis to be very common. How temperature goes out to be around 45 degrees in Australia in December. See, when we so obviously it is a southern summer at that point of time. In Australia, when you talk about the Australian Open, when does the Australian Open happen? In the month of January, in the first in from the second week of January, that is when the Australian Open picks up its peak. So at that point of time, 45 degrees is very rare. Generally, it is around 40 degrees that you observe. Now, why does that happen? It is summer in that part of the world at that point of time. So in summer, in certain areas, yes, you exceed 40-45 degrees, right? Even if let's suppose you assume 45 degrees as the temperature uh, of tropics in the summer. Let's assume 45. Still, the difference in temperature will come out to be how much? 55 degrees. At max, difference of temperature will come out to be 60 degrees, not more than that. But in the winter, the difference in temperature is substantially higher. See, understand, when you are comparing temperatures, a difference of even 5 degrees or 2 degrees is more than sufficient to bring about atmospheric changes. As we will study in the modules tomorrow, when we talk about, or even later today, when we talk about, let's suppose, conditions such as Indian Ocean dipole, you would be surprised to find out that even if the western portion of Indian Ocean, that is around the coastline of Africa, even if it is warmer than the eastern portion of Indian Ocean, which is hundreds of kilometers away in the region around Indonesia, even if the difference of temperature is 0.2 degrees or 0.25, 0.3 degrees, that is enough to bring about atmospheric changes across the entirety of the Indian Ocean, right? Across the two ends of the Indian Ocean. So a difference of temperature, even minimal though, here we are talking about a difference in temperature in the range of 20-25 degrees Celsius, which is humongous. But even if the difference of temperature between the summer and winter would have been 5 degrees or 7 degrees, that would have been enough to substantiate changes in the atmospheric circulation. Okay? Can we say frontogenesis leads to formation of fog? Not always. Not always. Let us take a look at the different types of front, and then you will realize why I'm telling you not always. Even though in majority of the cases, when there is a frontogenesis, it will lead to formation of the fog, but it is not a blanket case. It is not always the case. Why? So when we talk about the types of fronts, based upon which of the air mass is active, is it the warm air mass which is active? Is it the cold air mass which is active? Is it the case that both of them are in motion? Or is it the case that none of them are in motion? Based upon that, you have the classification into stationary front, cold front, warm front, and occluded front. So when we talk about stationary means something which is static, something which is not moving, which is immobile. So stationary front is a situation where the air masses, they come head to head and they don't move anymore. They are static, they are stuck to the same area. So that is what we regard as the stationary front. Then you have the cold front. In this, it is the cold air which pushes against the warm air. Here, the cold air is active. Cold air is active. And pushes against the warm air. Then you have warm front. As the name tells you, the warm air is active. Cold front, cold air is active. In the case of warm front, you have warm air is active. Active and pushes ahead. Then you have occluded. Occluded is basically from the term occlusion. Occlusion means the process of closing down, something which is closed down. So this generally gets created in very rare circumstances. When after the formation of a front, the front starts to close down from all sides. You have one type of air, that is cold air, which surrounds it from all sides. And that is when you have the occluded front. We'll talk about occluded front in greater detail. So here, when we talk about all of these fronts, let us pick up each one of them and let us try to understand their features. Stationary. Stationary front is when the air, cold air is coming from a region, warm air is coming from a region, both of them have come in front of each other, but none of them have sufficient energy to enter into each other's terrain or territory. Right? None of them possess that great amount of energy. So what happens in that case? In that case, the air lies static. So in that case, let's suppose the cold air is coming from this area. Eventually, it will enter this area. Eventually, it will come here. So like that, the cold air is progressing. Let's suppose it has reached here. Similarly, when we talk about warm air, earlier warm air might be present here. Then warm air might come up till here. Then the warm air would have reached here. Right? So eventually, due to that transition, the cold air and the warm air, they confront each other. But neither of them, none of them have enough power to push against each other. They have lost their energy in the process of reaching this place. They don't have enough power. So a stationary front forms when a cold front or a warm front simply stops moving. This happens when two masses of air are pushing against each other, but neither is powerful enough to move the other. So they lie static in the same place, right? So the air masses remain static in the same place. Okay. So that is the case of stationary front. Now, in the case of stationary front, what is it that you observe? Basically, if let's suppose after some time, cold air gains some energy, how will cold air gain energy? Or how will warm air gain energy? What is this process of air gaining energy? Air is always supplied from the region of high pressure. Air is never going to be supplied from a region of low pressure. Always air is going to be supplied from a region of high pressure, because air always blows from a high to a low. So let's suppose the high pressure has strengthened. That is the polar high from where the cold air is coming. So it might happen that after some time, after 4 to 5 days, the cold air might start pushing again. You can have the existence of a cold front. It can happen that after 5 to 7 days, the warm air starts pushing again. You will have the existence of a warm front. But simultaneously, what can also happen is that cold air and warm air, they don't push against each other anymore. They remain where they are, right? They remain static in the region where they are. So that is where you have the stationary front. Now, let's suppose after 10 days, 15 days, 21 days, there has been no movement. So slowly and steadily, the cold air will lose the cold conditions, it will start becoming warmer. The warm air will lose its heat. It will start becoming colder. So that transition, the region of or the zone of transition of temperature, that will be lost. What you will have is a region having unified or a uniform condition of air. So, if there is no movement at the region of the stationary front over a period of 2 to 3 weeks, after that, it can lead to frontolysis, where the air will gain each other's properties, it will become homogeneous and lose that frontal existence. So, if the air remains static in the same place for more than 2 to 3 weeks, they gain each other's property. Okay. And when they gain each other's property, leads to frontolysis. Because then the front won't be in existence. Then you don't have that sudden zone of transition from one condition to another. Now, in this case of stationary front, you won't have the occurrence of rainfall or inversion or fog formation. None of that will be observed in this case. Okay. However, when you have either of these air masses, that is the cold or the warm air which is in motion, things can be very different. For example, when we talk about the condition where you have the cold air which is moving ahead, understand this. Cold air is always going to be heavier as compared to warm air. And being heavier and slightly compressed, it is always going to stick to the ground. Warm air, on the other hand, is lighter. It has got a larger volume, density is less. It can be uplifted. But the cold air can never be uplifted from the ground surface. Generally, is always going to be sticking closer to the ground. So cold air, remember this as the property of the cold air. Cold air is heavier and sticks to the surface. Right? It is heavier, whereas the warmer air, being lighter, can be lifted from the ground. Okay. So when we talk about a cold front, we have seen that in the case of a cold front, it is the cold air which is active as compared to the warm air. It is the cold air which is active here. So when the cold air is active, think about it. Here in this region, you have the presence of warm air. The cold air is the one which is active. The cold air starts pushing ahead. Eventually, what will happen? It will push to the region of the warm air. So the warm air, observe its movement. As the cold air rams through, the warm air will be pushed violently and straightforward upwards. That will be its movement, isn't it? So the warm air will be straightforward, be lifted upwards, right? So in that case, what do you observe? When the air is suddenly lifted upwards, what will you observe? Its temperature will reduce. It will undergo saturation. And as it is lifted in the same region, condensation will happen at different heights depending upon which parcel of air undergoes condensation first. So you will have vertical development of clouds, right? You will have formation of cumulonimbus clouds. And cumulonimbus clouds are associated with heavy and violent rainfall, along with and associated with thunder and lightning events. So that is something you will find in commonality here. So when we talk about this particular region, so warm air is lifted above the ground. This warm air, as the cold air pushes in, warmer air is violently or is suddenly and violently lifted vertically upwards. What does that mean? That basically means formation of climate or weather observed conditions. You will have formation of cumulonimbus clouds, means heavy rains with thunder and lightning, and then other than that you will have the case of temperature inversion, frontal inversion, inversion, which will also happen because now the warm air is basically, excuse me, because now the warm air is basically uplifted straight forward above. So that is where you will experience a temperature inversion also happening. Now the rainfall which is caused here, is that rainfall convectional, orographic, or frontal? I hope now we understand what kind of rainfall is that. So what kind of rainfall is that, by the way? The rainfall which is observed in this case? It is very simple. Good. Frontal. So it will lead to frontal rainfall. This kind of cumulonimbus cloud bringing rainfall is frontal rainfall. You generally don't have the occurrence or the frontogenesis to be observed across India, right? It is generally observed, this entire process of frontogenesis is generally observed in mid to higher latitude, because that is where the cold and the warm air masses will meet. You don't have these occurrences happening over India. Now, the converse of it, that is the warm air. When we talk about, or rather the warm front. So when we talk about the warm front, what does that mean? Or what does that lead to? So warm front means it is the warm air which is active. And it is the warm air which is pushing into the region of the colder air. But again, warm air being lighter means the warm air will be able to rise up. Whereas the cold air being heavier means cold air will be hugging and sticking to the ground surface. Right? So what will be the motion in general? So here, if you consider this, let's suppose you have the colder air. They will have a definite compressed volume hugging closer to the ground surface. That is where you have the cold air. Now, as the warm air is coming in, this warm air will rise up across the incline. But this rise is not exactly vertical. In the case of the cold front, you had a situation where, in case if you consider the cold air, because the cold air was moving ahead, the warm air was lifted suddenly upwards, right? So that is why you had condensation happening across multiple layers forming cumulonimbus. But here, the rise of the warm air is very gradual. It is very slow. So it will lead to condensation, but it will lead to condensation over a vast and a larger area, not in vertical dimension, but in horizontal dimension. So that is where you will observe the formation of nimbostratus, altostratus, stratus type of clouds will be in existence. So here when we talk about weather conditions associated, conditions observed. So here, again, here also frontal inversion will be observed. Here also, you will basically observe in the case of stratus cloud formation. And stratus clouds are associated with what kind of weather phenomena? Moderate, continuous, gentle rainfall extending over larger span of time, where it can rain for many hours and days altogether, right? So here you have moderate, continuous, rainfall over a large area, which can also lead to formation of upslope fog. Why upslope fog here? Because it is rising up as if it is rising in the case of a slope. No, upslope fog is always associated with an orographic uplift. Orographic uplift means the air has been rising up because of the existence of a mountain in that area. That is what is associated when you talk about orographic uplift. Okay, so upslope fog is observed in the slopes as you move higher up across the hills and mountains. There you experience the upslope fog. I hope that is understood. Okay, till this point, everything is clear? Any doubts till this point? Feel free to ask if you have any doubts. Good. So I am assuming everything is clear up till this point. Okay. Now we come over to the last kind of front formation, which is an occluded front. Occlusion or occluded front is generally the final stage of frontal formation. Basically, when you have the frontal, now all the images that you see on your screen, these are basically the stages of your development of a temperate cyclone, which happens when you have the development of a front. Sometimes some of these fronts can lead to cyclonic formation also. Now here, you will observe that the front gets distorted. Initially, it was a stationary front. The front started getting distorted. The distortion increased furthermore. Why this distortion happens, we will come to it later on. But eventually, observe that the front closes down. Right, because on the ground surface from both sides, you have the cold air which has come over. So the front closes down. So that process or that stage is referred to as the stage of occluded front. So when you talk about occluded front, it is that stage before frontolysis where the front closes down from all sides because of the cold air coming closer to the ground surface or sticking on the ground surface, lifting the warm air from all sides. So this is observed before frontal formation or frontolysis as the front closes down from all sides. where the cold air sticks to the ground surface, and the warm air is completely lifted above the ground at the region of the frontal development. Okay, so that is where you will observe the formation and creation and existence of an occluded front. The weather conditions associated, the further formation of it in detail, we will talk about as soon as the next topic that we are going to cover about temperate cyclone. We will study these stages. So we will get a better idea about why this occlusion happens, when does this happen. But in general, you will observe that the front starts or keeps on getting distorted. Eventually, it will be distorted to such an extent that it will appear to close down. And that is the stage of occlusion. Occlusion basically refers to the process of closing down. Okay, we will cover it in much more detail immediately after this. Don't worry. Now, we come to the portion of cyclones. So, cyclones, something that we have heard from our very childhood days, happening across the coastlines of India. But these cyclones also have got further amount of classifications based upon where do they occur. If they occur in the regions that is in the mid to high latitudes, mid latitudes generally, they are temperate cyclones. Temperate cyclones, they occur over very vast area. The diameter of the cloud formation due to a temperate cyclone, that can span to 750 kilometers or 1000 kilometers in general if you talk about the entire area of disturbance. But then, when you talk about the tropical cyclone, something that we are frequently experiencing in India, the tropical cyclones are the ones which hit India. Now, these tropical cyclones, they are much smaller, right? But they are much more powerful. So, that is something which you study in this case. But cyclonic formation, the existence of a cyclone, means what? That due to extreme low pressure, not a normal low pressure. Normal low pressure will always attract winds. Extremity of low pressure, very intense low pressure, which is created, that attracts winds. And the winds, cyclone, refers to a circular motion. So the winds, they come in towards that low pressure and they circulate, right, in a kind of a circular motion, clockwise or anti-clockwise. It varies whether you are in northern or southern hemisphere. So that is what is a cyclone. Created, it is of two types, and the formation of both of them are completely different. When we talk about a temperate cyclone, that is its formation, its existence, it is very, very different from that of a tropical cyclone. Okay. So here, these are intense low pressure areas, very intensive low pressure regions. Why do and how do these intense low pressure regions get created? Either due to extreme form of heating or temperature conditions, or even due to dynamic conditions. Let's suppose in a region, winds are converging and they are rising up substantially at a very high pace. Low pressure, extensive low pressure. If more winds are rising, more low pressure. So that low pressure can be created both due to thermal and dynamic conditions. I hope that is understood, Justin. So, both due to thermal and dynamic. So, that means in these low pressure areas, winds, they are Coming in, they are attracted from all directions, and these winds then they start circulating, they start rising up. So here, when we talk about cyclones, the opposite of it is anticyclone. Cyclone is extreme low pressure. Anticyclone is going to be the case of extreme high pressure event. So the wind circulation around a low pressure is called a cyclonic circulation, and around a high pressure, anticyclone. So observe this. On the ground, if you have low pressure, winds are going to be attracted from all sides. They will also rise up, and rising air is what forms the clouds. Sinking air will never lead to the existence of clouds. It is always rising air. Why? Why cannot sinking air form the clouds? Because for cloud formation, you need condensation to happen. Condensation will happen only when the air becomes colder. Air will become colder only when it is rising up. So always in the region around rising air column, you will find the presence and formation of clouds. But wherever you have a sinking air column, you will never have any existence of cloud formation. So in the case of the cyclones, because the winds are attracted towards the low pressure and the winds then start rising up, you will have distinct and significant cloud formation. Whereas in the case of the high pressure, that is where you have lack of rainfall, and the winds they will impacted by the Coriolis force in the region of the anticyclones. Anticyclonic circulations are created across extreme high pressure areas. Cyclonic circulations are caused near extreme low pressure areas. Okay, but the circulation of the wind in itself, that is different when you talk about the northern hemisphere and the southern hemisphere. Observe this. This is the image for the region of tropopause, the cloud formation that you observe at the top of troposphere during a cyclonic event. This represents a tropical cyclone, right? So cyclone brings about circulation of the wind. So a circular movement of winds around the region of low pressure. Region of low pressure. Now, this circulation is different in the northern hemisphere and circulation is different in the southern hemisphere. Why? Because of Coriolis force. So when you talk about this low pressure, so obviously cyclones will be in existence only in those regions where that circular movement can be attained. And circular movement is attained because of the existence of Coriolis force. So in a way, we can go for a deduction that cyclonic circulations will be in existence only in areas where you will have the Coriolis force in existence. Which is the region on the planet where Coriolis force is absent? Let me know. Is there any region across the planet where we have zero Coriolis force? If yes, where? Shahid, Ayman, Akshat, Ganesh, Parshuram, Akash. So you are saying that at the region of the poles, the Coriolis force is zero. So where is it that it is maximum in that case? The Coriolis force? Gaurav, Satyanarayan. Where is it that the Coriolis force is maximum? Center. Hmm. Equator, it is maximum. Okay. Means no revision has happened about the previous weekend. Previous weekend, you celebrated the weekend, that the weekend is done. Through the week, you would have basically watched the World Cup, had a jolly good time. And remember, I told you, if you don't revise what has been taught in the previous weekend, your understanding of this weekend is going to be incredibly tough. Because all the phenomena from El Nino, La Nina, everything, Indian monsoon is going to revolve around the discussions that we have had in the previous weekend. So, just to repeat it, and I won't be repeating it quite often. So, at the region of equator, Coriolis force is zero. The Coriolis force tends to become maximum at the region of the poles. Okay, so Coriolis force is always zero at the region of equator. Coriolis force is always maximum at the region of the poles. So if you don't have any Coriolis force at the region of equator, means this circular movement of the wind will also not be attained. That is why at the region of equator, you will never experience cyclonic circulation. You can experience it 5 degree north, 8 degree north. You can experience it 10 degrees south, 8 degrees south. But at the region of equator, you will never experience any Coriolis force and hence no cyclone. Okay? Maximum Coriolis force above equator. No, Shiva. Incorrect. Above at the region of equator, Coriolis force is 0. Is that clear? Are you guys able to recall that? Or is it something that I am talking simply going tangential? Okay. Because so many of you have said that Coriolis force at equator is maximum. Even I sometimes get confused that whether it is my fault or something. But understand, the circulation in the northern hemisphere, when we talk about circulation in northern hemisphere, yes, Anuranjan, that is good. So circulations in northern hemisphere, how do they happen? So cyclones are regions of intense low pressure. Intense low pressure means winds will be attracted from all directions. From all directions, the winds will be attracted. Now, when we are talking about northern hemisphere, the winds will get deflected in which direction? Rightward or leftward? Okay, it gets deflected in the northern hemisphere in the rightward direction. So here you will observe the winds getting deviated towards they want to come to the low pressure, but because of the Coriolis force, they will be bending in the rightward direction. All these will be bending in the rightward direction. Now, if suppose I ask one of you to go there and stand at the center of the low pressure, now if I ask you report the wind movement, direction of the wind movement, what is it that you will observe? You will observe that around the region of the low pressure, the wind is moving in a direction somewhat like this, isn't it? What is that direction? This is basically counterclockwise or anti-clockwise. So here you have anti-clockwise movement of winds in the northern hemisphere. And what about the southern hemisphere? When we talk about the southern hemisphere, the only difference is that the wind will be deviating to the left here. So you have extreme low pressure. The winds are coming from all different directions, but they will be deviating in the leftward direction. So they will be deviating leftward. Leftward. Again, if I ask you to repeat the same process, where you will have to stand here and report the direction of the wind movement, you will observe what direction of wind movement? Somewhat like this. This will be clockwise. That is your clockwise wind circulation. Okay, so in the northern hemisphere, if there is a cyclonic circulation, the direction of the wind movement is anti-clockwise. In the southern hemisphere, if there is a cyclonic formation, direction of wind movement will be clockwise in nature. Now, when we talk about anticyclone, that is the region where the air is sinking. You have the subsidence of air. So observe this area. This is obviously taken up from space. So if you observe this area, all around it you will have cloud formation. But here you have an absolute lack of cloud. What does that indicate? That from all the regions, the air is sinking in this area. Many of the times, even from the ground surface, you would be able to observe these conditions, especially in the northern India, especially during the coming months. You will observe these. For example, those of you living in the region of northwestern part of India, already in the cases wherever you observe some amount of cloud, you will observe in certain sections that you have cloud all around, but suddenly in a large chunk, it is absolutely clear, which tells you air is sinking in that area. So here you have the sinking of air. Now, air, when it sinks, air sinks from above region. It hits the ground and then it simply moves in all different directions. So there also you have some amount of circulation of air which is resulted. So when you talk about the northern hemisphere in this case, in the northern hemisphere, what is the circulation? So wherever you have a high pressure in the northern hemisphere, so the air is sinking and then is moving away. But here the air will be bending in the rightward direction. So what will the air bend look like, or the air circulation look like? The air and the wind will be moving in rightward direction. Yeah. So what is the circulation pattern here? It is clockwise. Circulation. And what about the southern hemisphere? When we talk about the southern hemisphere, everything will be same around the region of high pressure. But the air will be bending in the southern hemisphere in the leftward direction. So that circulation will be what? It will be anti-clockwise. Clockwise circulation. So regions of high pressure or anticyclone, no rainfall. Regions of cyclonic circulation, very heavy, very intense rainfall, very thick cloud formation will be observed always. Because anticyclone is associated with sinking air, and sinking air can never lead to cloud formation. It is only the rising air which can lead to cloud formation. Okay, so that is why you will observe in general around the pressure systems of cyclone and anticyclone, basically around the region of cyclone where you have the low pressure, that is where intense low pressure leads to cyclonic formation. Pattern of wind direction in the northern hemisphere is anti-clockwise for cyclone, southern hemisphere it is clockwise. For the anticyclone, the pressure condition at the center is high. Then in the northern hemisphere you will have clockwise circulation, in the southern hemisphere anti-clockwise. I would advise you very strongly, please don't memorize it. Please do not learn it, because the moment you learn it, you will open up the scope for committing mistakes. Rather, try to think about it. Take a piece of paper immediately after this also, or at the end of the class, take a piece of paper, try to chart it out on your own. How does it figure out? You will observe that around the low pressure, winds are coming in, they are converging, and in the northern hemisphere bending to the right, in the southern hemisphere bending to the left. Opposite of it in the case of the high pressure. Just draw it out on your own. You will be able to arrive at this on your own, so that there is no mistake which is committed. Okay, just ensure that this is something which is not ruttified or rote learned. Okay, now after this we come to the portion of temperate cyclones. We'll take it up after the break. Priya, please repeat what? In the region where you have cyclones, because of very thick and dense cloud formation, you will always have very heavy rainfall, strong wind movement, thunder, lightning, etc., which is associated with it. In the region where you have anticyclonic conditions, because you have sinking air will never lead to cloud formation. Hence, anticyclonic conditions lead to drier conditions, lack of rainfall, right? Sometimes it can lead to rise of temperature as well. Okay, the last slide. Okay, so I hope this is understood, right? So now we go for a break. Take your lunch break. Be back at 4. We will start at 4. Okay, we'll start at 4 p.m. There we'll talk about temperate and tropical cyclone.